The next derivative of carboxylic acids that we're going to study is the ester. And we are going to do this in two sections instead of all in one section. First, we're going to look at the ways of making esters. And as a reminder, this is the ester functional group. It looks a lot like a carboxylic acid. So there are three different ways of making an ester that we're going to go over, and they're not, some of them are reactions that you already know, like the SN2 reaction. We really haven't looked much at using SN2 to synthesize an ester. In fact, we maybe didn't look at it at all when we were doing SN2s. To do this reaction, we're going to use a deprotonated carboxylic acid, so that's called a carboxylate, and we are going to react it with some sort of alkyl halide, and we're just going to get like the standard SN2, like that. And so because this is an SN2 reaction, the alkyl halide cannot be tertiary. So that's just a standard SN2 reaction. The formation of this, it's called a carboxylate, the deprotonated carboxylic acid. That can be just as simple as taking a carboxylic acid and reacting it with a strong base. And that strong base is just gonna, ooh, that's not what I wanted to have happen. The strong base is just going to pull that hydrogen off of the carboxylic acid. So that's one way to synthesize an ester. The second way is called a Fischer esterification. This is the same guy that did the Fischer projection. It's the same Fischer. So for this reaction, we will take a carboxylic acid and we will take an alcohol, which I'm going to do as R prime, and this is an acid catalyzed reaction, and we get an ester out of it. And it also makes water as a byproduct. And we're going to do the mechanism for the Fischer esterification on a worksheet, so you are going to get a chance to see it, and it's a pretty straightforward mechanism. And then last but not least, the third way for synthesizing esters, you just learned, and that is converting an acid chloride or an acyl chloride to an ester using what your book calls it alcoholysis reaction. So taking an acid chloride, reacting it with an alcohol. Whenever we're doing these acid chloride reactions, we have to use pyridine as our solvent to suck up HCl, and this gives us the ester.